Here we go, video number 2. We start with example 5. This is one for students to try on your own. So again, pause the video, work out the problems, check your answers. The solutions will appear in 5, 4, 3, 2, 1. What are the solutions? Hopefully we are in agreement. If there's anything that we disagree on, please look at the steps and see if you could find out where we disagree and go from there. And if we're not able to find how to correct a problem, then we'll talk about these in class or in seminar and clear things up. Let's move on to example 6. We're asked to find the perimeter and the area of the rectangle if x equals -9. So let's first substitute -9 in for x in each side and see what we get. Starting with the top side. If x is -9, we'll put -9 in place of x, which will make -9 squared plus 4. We'll do the exponents first, right? -9 squared is -9 times -9, positive 81. 81 plus 4 is 85. So the top side is 85. Now we'll look at the right side. The right side is -2 times x. So we'll substitute -9 in place of x. So give us -2 times -9, which is positive 18. So the right side is positive 18. So remember some properties of a rectangle. If the top side is 85, then the bottom side is 85 also. If the right side is 18, then the left side is 18 also. So we find in the perimeter of a rectangle. We're going to add up all 4 sides. So we can do the top plus the bottom, and then we'll add the left side and add the right side. Okay? You might be familiar with seeing this as 2 times 85 because the top and bottom are both 85, and 2 times 18 because the left and right side are both 18. Either way you write it out, it means the same thing. So let's see, this will give us 170. This will give us 36. So we can say that the perimeter is equal to 206. Now, they don't say anything in here about units of measure. We don't know if this is supposed to represent inches or centimeters or miles or millimeters or whatever. So we won't put any units in our answer. Now let's go find the area. Remember, the area of a rectangle is found by multiplying the base times the height. So the base is 85 and the height is 18. And we'll multiply these together. We'll get 1530. Again, they didn't give us units. We don't know this is inches squared, centimeters squared. So we won't include units that weren't provided in the problem. So keep these ideas in mind whenever you're doing area and perimeter problems, because they're going to come up off and on throughout the rest of the year. When you're ready, let's go on to example 7. In example 7, we're going to introduce a new notation to you. It'll make more sense when we explain why function notation is sometimes used in class. That's better to do face-to-face. But just so you know, sometimes an equation is written with function notation, which means instead of y equals something, they'll say f and then parentheses x equals. And that is read, if you're going to say it out loud, f of x. F is a function of x, and again, that doesn't mean anything to you right now. We'll discuss this idea in class and clear up what it means, but let's just get first familiar with the symbols. If you notice that in the original problem, they have f with x inside of parentheses, And in the problem that we're supposed to work out, the x has been replaced with a 5. So what this means to us is that on the right side of the equal sign, everywhere there's an x, we're going to replace the x with 5. So instead of 2 times x squared plus 2 times x, we're going to make it 2 times 5 squared plus 2 times 5. And now, once again, we'll just use the order of operations. The first thing to look for is something to be done inside of grouping symbols. Well, we have parentheses here, but there's no operation inside. There's no adding, subtracting. So we'll just do the exponents first. 5 squared is going to make 25. 5 times 5 is 25. Now we'll go to step 3 of the order of operations. Look for all multiplying and dividing from left to right. Well, we can multiply 2 times 25 and get 50. We can multiply 2 times 5 and get 10. And finally, step 4 of the order of operations, we'll do all adding and subtracting from left to right. Well, there's only one addition step to do. 50 plus 10 equals 60. So f of 5 equals 60. This can mean a lot of different things in different contexts. We'll talk about the meanings of this in class. Let's just get familiar with the symbols, and we'll apply meaning next class. So here we go. Moving on to the next problem. They want us to evaluate f of negative 3. So what do you think we're going to do? That's exactly right. We're going to replace all the x's with negative 3. We're using the same equation that they gave us back here in the beginning of the problem. Let's get started. We're going to replace all the x's with negative 3. So if 2 times negative 3 squared plus 2 times negative 3. So again, there's no operation to do inside the grouping symbols, inside the parentheses, so we'll look at the exponents. Negative 3 squared is negative 3 times negative 3, which makes positive 9. Now you could look at the next step different ways. The way I look at it, I would say we're multiplying something that looks like a positive 2 times a negative 3. So positive 2 times negative 3 makes negative 6. We're going to write minus 6. Okay, next we'll multiply. 2 times 9 is 18. And then finally we'll do the subtraction. 18 minus 6 is 12. So f of negative 3 is 12. Why don't you guys try example 8 on your own and then check your answers. But I got to warn you, you've got to be a little bit careful. They're using a different set of rules here for f of x. This one's a longer expression. So you can see every time you replace a letter x, there's going to be 1, 2, 3 x's in the expression for us to substitute for. Go ahead and try number 8 part A and try number 8 part B with the video pause and check your answers. The answers will appear in 5, 4, 3, 2, 1. Here you go. Here are the solutions. We substituted negative 2 in for x for part A, substituted 5 in for x for part B, and then we perform the order of operations one step at a time. Hopefully this makes sense. If not, I'll bring some questions to class and we'll clear them up. Let's move on to examples 9 and 10. In example 9, we're asked to complete a circle. So all we're going to have to do is do repeated substitutions. Number 9, they give us this equation. They say f of x equals negative 2x squared plus 3x minus 5. So we need to substitute a few values in for x. First, we're going to start with x equals negative 5. You see that negative 5 is in the x column. So we know that we're going to put negative 5 in place of x. So f of negative 5 is going to be negative 2 times negative 5 squared plus 3 times negative 5 minus 5. This is going to give us negative 2 times 25, because negative 5 squared is 25, plus 3 times negative 5 minus 5. So negative 2 times 25 is negative 50. 3 times negative 5 is negative 15 minus 5. And now we'll do the subtraction. Negative 50 minus 15 is negative 65. Negative 65 minus 5 is negative 70. That means when x is negative 5, f of x is negative 70. Okay. Now, we're going to start over and repeat the process, this time putting negative 2 in place of x to the same equation, same function. So, say f of negative 2, negative 2 times negative 2 squared, plus 3 times negative 2 minus 5. And we'll replace all the x's with negative 2. So to the exponent, negative 2 squared is positive 4. So get negative 2 times positive 4. 3 times negative 2 is negative 6. Minus 5. So get negative 8 minus 6 minus 5. Negative 8 minus 6 is negative 14. Negative 14 minus 5 is negative 19. So when x is negative 2, f of x is negative 19. And now we repeat for when x is 0 and for when x is 3. Why don't you evaluate those on your own and then check your answers. Pause the videos, do the scratch work, and check your answers. Make sure you press pause before the answers display. The answers will display in 5, 4, 3, 2, 1. Here you go. Check over the answers. If we agree, awesome. If not, well, then let's try to make some corrections. Hey, we're going to end the video here, and I'm going to show a separate video for number 10. Number 10 is an extension problem. That's going to be one of the level 4s. When you're ready, go on to the third video and watch the explanation for example 10. Thanks for watching.